This is part 1 of the MCP Security series. In the introduction section, I have shown the tentative table of content, and in this video, I will discuss about MCP server authentication using the bear token. The basic setup used in this video is very simple. We will have MCP server implemented using FastMCP library and MCP client also using FastMCP library. And MCP client will use a bear token in order to authenticate with MCP server. This way, we will enable and disable anonymous access to the MCP server fast, protecting the privacy and data. That said, let's start with the code implementation. Now let's look at the code which we need to implement to protect our MCP server with bear token authentication. Bear token authentication is one of the simplest method of authentication. Then a client parses a bear token. In this case, the bear token will be called my secret token. And this token is passed using the authorization argument of the HTTP headers. So once the HTTP request comes from the client to the MCP server, it will check whether HTTP header has authorization attribute and extract the token from authorization attribute. If this token will be the same as the token we expect to see, the server will allow further operations. If not, the server will generate the unauthorized error. Of course, there is a big problem with bear token that if you intercept that bear token and it is not encrypted, then the intruder will have a full control over your server. We will discuss how to overcome these issues in the later videos, but for now we concentrate on the bear token mechanism. So in order to enable extraction of bear token from HTTP header, we will have to implement a middleware or auth middleware class using the middleware object from FastMCP server middleware. And we are using FastMCP library as a basis. Now, if our authentication fails, we import tool error from FastMCP exceptions. And finally, we import get HTTP headers from FastMCP server dependencies. So here we explicitly define our bear token, and we define environment variable MCP bear token, and the value for the bear token is my secret token. We define MCP server using FastMCP and then providing the server name. In this case, this is secure server. In order to enable authentication using bear token, we are adding authentication middleware, which we have defined here. And the addition is done using mcp.add middleware. Now, our MCP server also has a tool. We define a tool using mcp.toolDecorator. And in this case, this is very simple to get private data. And everything that tool is doing is just returning this is protected data. Finally, we will have to run our MCP server using run method. We select the transport HTTP, which means our MCP server will run using streamable HTTP transport. And we deploy it at localhost, basically 0.0.0.0 IP address, and we'll run our server on port 8000. Now, let's have a closer look how the middleware is organized. I have already mentioned that middleware is using get HTTP request function in order to extract HTTP request which has been sent from the client to the server. But it is very important to understand the structure of middleware. So the middleware enables to intercept events which occur on the server. So there is a list of events. We will talk about those events later in this series of videos. But one of the key events which are generated by the MCP server is on call to event. So then a client is calling a particular tool. So in this case, middleware intercepts this event, and we provide a context as a middleware context. Basically, this is all the information about the current session and every parameter of the MCP server. And also we will use call next object. So call next is necessary to go next along the implementation line within the context of MCP server. Basically, in this particular case, call next means that after we check the bearer token, and if bearer token is correct one, we will release the process, we will release this on call to event, and we'll proceed with the tool execution. Otherwise, if we do not confirm content of the bearer token, so bearer token is different from the one we expect, we will break the runtime of the server and we will not invoke the tool. So this call next is serving as a next step in MCP server implementation. In this particular case, this means invocation of get private data tool. Now that it's clear how MCP server allows bearer token authentication, let's have a look at how should we structure our code for the client. So for the client, we will use a client object from FastMCP library, and we will use a bearer auth object from MCP client auth. Also, we will use OS and async IO. So first of all, we will define our MCP URL. And we know that the MCP server will be running at localhost port 800, and the endpoint for the MCP will be /MCP. Next, we are using the same bearer token, which has been defined for the MCP server, my-secret-token. And we create the environment variable for the bearer token as well. In the main function, we will instantiate our client, and we provide MCP server URL. And instead of creating HTTP request of authorization header directly, we are using bearer authentication object where we pass our bearer token. And next we call our client asynchronously, and we call a particular tool. We know the name of the tool, get private data, and that tool does not require any parameters. So the structure of the response, which we assign to the result variable, is very complex. So here's a shortcut to get the text response back. However, let me run the client once, and we will see in-depth investigation of what is a raw look of the response object. So first, let me run the MCP server. So in order to run MCP server, I have to run the server file, which is Python MCP server bearer token. Let me run this. And now our MCP server is running at localhost port 8000, and the endpoint is MCP. So in the second terminal, let me run the client. So it is Python MCP client bearer token. Okay, and this works. Now, as I have explained, if authentication fails, the server will raise tool error exception, and server will say that we are unauthorized due to the invalid or missing bearer token. So it is easier not to rerun the server to break the bearer token on the client side. So let me erase a hyphen, save the file, and run the client again. And since the bearer token which we are passing from the client to the server is different from the one that server expects to see, we are getting the tool error and the message we are unauthorized and invalid or missing bearer token. And as we have expected, the server didn't let us go further to invoke the tool. So this is how bearer token authentications works for MCP server using FastMCP library. Now let me fix the correct value of the bearer token, and let's have a look at the raw structure of the MCP server response, which is stored in the result variable. So let me now print result variable as is. Okay, and you can see this is a tool call result, and it's a tuple containing context, and the context is represented as a list, and we have a structured content where result is protected data. So what we can do, we can run a dict method __ dict _ in order to see what are the possible keys for the result object. So let me run the client again. Okay, and now I can see that I have a content key and I have a structured content key. So in the previous code sample, I was using content as a key, and then it was a longer path to actually get the text output. Now, since we have a structured content, let me use this key. And since structured content is a dictionary itself, I will use another key, result, within the structured content dictionary itself. So what I will do is I provide a structured content, and another key is result. So let me save the code and run it again. So let me clear the console, and that we are looking at the HTTP response. Okay, let me send and rerun. All right, so as expected, we have this is protected data response, which is provided by the tool. And middleware helps us to authorize access to the tool using the bearer token. So thank you very much. This concludes the introduction how we can use authentication for MCP server using the bearer token. In the next part, we will consider how we can increase the level of protection by using JavaScript web tokens instead of simple bearer tokens, which are unprotected. And also, I encourage you to have a look at my earlier video where I introduce the basics of MCP servers, how to connect MCP servers to the API endpoints, and how to use MCP proxy servers in order to unify all the MCP servers under one endpoint. So I hope you like the video. Please subscribe and like it. Thank you.